All right, imagine you're reading a story one sentence at a time. The meaning of each sentence depends on what came before, right? That's exactly the challenge when it comes to teaching AI to understand language, time series, or any kind of data where order matters. And that's where recurrent neural networks, or RNNs, come in. Now, most regular neural networks process information all at once, like looking at a photo and making a decision. But RNNs? They're built to handle sequences step by step, like listening to a song, one note after another. Why is that special? Because sometimes, what happens earlier in a sequence changes the whole meaning of what comes next. Here's the cool part. RNNs have loops in their structure. Think of it as a little memory bank that gets updated with each new piece of information. If I say he went to the bank to, you don't know if I mean money or a riverbank until I finish the sentence. RNs use their memory to keep track of what's happened so far, so they can make smarter predictions about what's coming up. But there's a catch. If the sequence gets too long, RNs can start to forget things from way back at the start. This is called the vanishing gradient problem. It's like trying to remember the first scene of a really long movie. It gets fuzzy. To fix this, researchers came up with a couple of clever upgrades. First, there's the long short-term memory network, or LSTM. It's like giving your RN a notebook so it can jot down important stuff and not forget it, even if it's a really long sequence. Then there's the gated recurrent unit, or GRU, which is a bit simpler but does a similar job, helping the network decide what info to keep and what to toss as it moves through a sequence. So where do we see RNNs in action? Tons of places. In natural language processing, RNNs help with language modeling, predicting what comes next in a sentence, generating text, and even analyzing sentiment. They're also behind the scenes in speech recognition, turning your voice into text for virtual assistants like Siri or Alexa. Without RNNs, these systems wouldn't be able to understand the context behind your words or follow along with your commands as they unfold. The big takeaway? RNNs mark a huge leap in making AI that doesn't just see data as isolated dots, but as stories, where context, order, and memory matter. That makes them a key building block for AI that thinks just a little more like us. Pretty wild, right? Thanks for hanging out with me and diving into the world of RNNs. If you want to keep unlocking the secrets behind AI, hit that subscribe button and stick around for more.